Good morning, students. In this lecture, we are going to discuss about the operators and its precedence and associative in C language. Right. Now, you consider the operator as here we are having now the first one as our highest priority, right? So, open bracket, close bracket is a highest priority. So, here we consider now the open bracket, close bracket, or otherwise we are having now this is a square bracket for array reference. Array reference means here A of, then here we are having the index. The index may be an expression A of I plus 1. So it will evaluate the expression and you will get now the index value and then access the array. So A of I, then we are having two-dimensional array here J plus 1, like we are having now the expression. So this is having highest precedence per square bracket, right? So open bracket, close bracket, this is in the expression as here we are having now A plus in the X plus Y. What do you mean by that one? As X plus Y is having highest priority than that A plus. So that is here. If you are having that open bracket and close bracket, first you have to complete the open bracket and close bracket. So that is highest priority and array indexing. And then we are having now the arrow. So here we are having that structure, right? So structure variable, then with then one field. Structure with one field. Then you have to use the operator. So this is a direction operator. We can have array of structure member access, right? So this is called structure member access. So this is a structure variable. Then we are having now the access and field, right? So one array, one structure. Here, for example, the student structure, name, then ID, then department, like we are having that field. Structure, the student structure, and the structure is having the name ID. So that one as the structure variable, you declare that one as S1 as a pointer. Then you can use now the pointer with one field. If you want to have that one, then we can use that array structure member access. So this is called structure member access. And then the postfix increment or decrement, right? So that is increment I plus plus. I plus plus is here, I plus plus, then A plus plus. So that is called postfix increment or decrement, A minus minus. Increment or decrement, that also is having the highest priority. Then we consider now next, this is left to right. So it will evaluate if you are having both are equal priority, X plus Y plus Z. Now here we are having left most first and then both are equal priority, then you have to go for evaluate the left to right evaluation. So that is called associative left to right. And then we are having now the next highest priority is here unary operator, right? Unary operator is minus A plus 5 plus B or something. Then the unary operator is having the highest priority. Unary operator. Unary operator is here. Unary means the minus sign with the variable x minus x or minus p plus or minus p. Then we have that one. This is we are having now that one as unary minus. Unary minus we can have now. Then we can have that prefix operator plus plus I, then plus plus j. So that is we can have now. And here we are having now unary operator plus minus. Then we are having now exclamation symbol, not of. Exclamation symbol is not of. So that is here if you are having that one A x less than y, not of x less than y. Then here we are having now the highest priority, that not operator, right? Then we are having now the not, and here we have the address T referencing. T referencing means here x equal to star A. The star A is a pointer, then star A is a T reference. So we are having this reference. Then from that reference, we are getting that value as star A. So that is T reference operator. This one is T reference operator. So T reference operators, if you are having a pointer, using the pointer, you want to get the corresponding value, then you put that T referencing operator and assign. So that is the P is a pointer. From the pointer, we are getting that value and then we are assigning. So this is called T referencing. and then we are having address of operator. Address of operator is address of that x. So that is x is a memory location. Then here which address that x is reside, then that address is having now this address of operator. So we are having now pointer is address. So we are getting now that variable address through ampersand. Right. Then we are having typecasting. Typecasting is suppose we are having 4.5 and we make it as integer, then you are giving that integer equal to some integer variable. So it will give 4.5 is converted into 5. 4.4 is converted into 4. Then 4.7 is converted into 5. Like it will convert that integer type. So this is called typecasting. The typecasting is the next level priority. And then multiplication division. Multiplication division and modulus operator. Multiplication division on modulus operator. Right? So this multiplication division and then we are having modulus operator. So A mod 3 modulation operator. This modulation operator is having the next level priority. Modulus. This also left to right, right? So this is we are having now right to left. So it will evaluate this right hand side to left. So this is we are having now this one as right to left, right? So for that we are having this operator. So this is right to left, and then we are having now these are all the left to right, right? So this is here a plus b, x plus y, x plus y or x star y, right? Multiplication x slash y. So this is left to right evaluation. X slash x star y star is set. So this is one, and then it will evaluate left to right. And then addition subtraction. Next level is we are having now addition subtraction, adding that number and subtracting between that number. And then bitwise operator. So here shift operator, bitwise shift operator, shift left and right, right? So this is we are having now. This is shift left. So this is shift left and this is shift right. So 2 less than symbol is shift left, right? So shift left. So this is shift right. So greater than symbol is right, left, right. So this also left to right evaluation. So associative is left to right. And then we are having less than or equal to, greater than or equal to. Less than or equal to, greater than, and greater than or equal to is the relational operator. Then the relational operator is for Boolean expression. We are having the relational operator. This is also left to right, right? So here x less than or equal to y. X less than or equal to y. So this is a Boolean expression. The result is either true or false. Less than or equal to, right? Then we are having equality operator. Double equal is we are comparing that one, both are equal, and not equal to is exclamation equal. So this is equal operator. Then this is not equal to is not equal to. So we are getting now that one as x equal to y means then this is either true or not, right? So x equal to 10 and y equal to 10, then x equal to y is true. X equal to 10, y equal to 20, the condition is false. So that is here equal, then not equal. And then bitwise AND operator. So here this is bitwise AND operator, then bitwise exclusive OR operator, and then bitwise OR operator. Then this is a logical AND. So if you are having two conditions, x less than y and y less than z. So this is we are having now y less than z. So this is we are having logical and logical OR, x less than y or y less than z. So this is we are having now logical OR operation. Then we are having now the ternary operator, right? So that is here x less than y question mark. Then we are having here 4 colon 5, right? So equal to z, right? So z is assigned. If the condition is true, it assign 4. If the condition is false, it assign 5. So this is a ternary operator. It's a ternary operator. Question mark with colon, right? So that is here we are having no ternary operator, and then we are having that assignment operator. Equal is assignment operator. Then we are having that we are having now some associative, right? So x plus equal to y. X plus y equal to, actually x equal to x plus y. Already existing value and added with that y. X equal to x plus y. So that is can be written as, now here we are having now x equal to y x plus equal to y, we can write it. That same way we are having plus equal to, minus equal to, star equal to, slash equal to, modulus equal to, then shift equal to, then ampersand equal to. So all operator we can have now some associate rules, right? Then that one is we can have. Then we are having the last one as comma operator. Right. Now we will see that one simple program, the example program we can have. Right. Here we will see that one. In that case, you consider now. Right. So that is a equal to 5, p equal to a equal to 10, p equal to 5. Then what's the value for c? Right. So here a plus b. So a plus b is a addition. So additions we are getting now 5 plus a plus b. The result is 15. So a plus b. So a plus b equal to, then the percentage d is we are adding that number. So this is the number we are adding, we are placing now. A plus b equal to 15. And similarly here a minus b. So a minus b is a minus b. So we are getting now this result a star b. We are getting the result. Then a slash b, the division. Then we are having modulus operator. A is 10, a equal to 10, p equal to 5. So 10 modulus 5. So 10 divided by, so we are getting the remainder is 0 only. 10 divided by 10 divided, so this is divisible, there is no remainder, so the remainder is no remainder, so you are having 0 here. This is a modulus operator. And then we are having the relational operator. Now here you see this one, relational operator. So that 1 is true, 0 is false, right? So that is here a equal to b. So whether both are equal or not, right? So you are getting now this one as a equal to b. We are getting the result is 1. So 1 is actually what it is? 1 is true. Right? Then here not equal to b, then here we are having not equal to b, sorry, this is true, right? False. So a not equal to false, right? So a equal to b is false. Then a not equal to b, so the condition is true. Then here a greater than b, condition is true. Then a less than b, condition. So a is 10, p equal to 5. A equal to 10, p equal to 5. So the result is here a plus b. So that condition is false. So that is we are getting now 0. 0 is represented as false. 1 is true. True and false. Here we are having now a greater than b. That value is 1. So a less than b, less than or equal to b, the false. Right. So that is here we are having relational operator. And then we'll have the logical operator, right? So x and y. So x here we are having now, and so x and y, the x is here we are having now x and operation y, right? So x is here 10 is actually what we are having now 1 0 1 0. Then y is 5 0 1, right? Then we are doing the bitwise and all are 0. So we are getting now the result is 0. Right? So that is here the logical and, right? So logical and is, so x is true, y equal to true, and we are having now that one was value is false. Something wrong. So and or operations, right? So here we are having now x or y. Then we are getting now this one is true. Then not of x. So not of x is we are having now the false, right? So not is here positive value. So here we are having this is positive value, this is positive value, right? Then here we are having now this and we are giving that value. Logical operator we are having now as x is true, y is true, and operation we are getting now this is true. What is the case? XY. Okay, the XY value is different, right? So that is here. What's the value for X? X is 1, Y equal to 0. X is 1, Y equal to 0. X is 1 and Y equal to 0. So X is true, Y is false. X1, Y equal to 2. So that result is it's not that. Then here we are having now XY, right? So that is here. So in that case, x equal to 1, y equals 0. So 1 and 0. So 1 and 1 is 1, 1 and 0, 0. then 1 or 0, this is the result is 1. So that is true and false. So the result is false. Here, true or false, the result is true. Then here we are coming 1, not of 1 is true, the not of true is false. To not of true is false. Then we'll go for bitwise operator. A, B, right? So A and B. So A and B is, here we are having now, A is 10, B is 5. Then we are doing now that one as A equal to 10, B equal to 5. Then bitwise AND operation is here 0, 0, 0, 0. So bitwise AND operation is, we are getting now the result is 0. So the bitwise AND operation, the result is 0. Because of that bitwise AND operation. So we are having 0 and 1, 0, 1 and 0, 0, 0, 1, 0, 0, right? Then we are having R operation. So that is here 1, 0, 0, 0, 0, 1. Then we are doing R operation 0, 1, 1, 1, 1, 1. So the result is 15. So this is result 15, right? So that is 2 power 0, 2 power 1, 2 power 2, 2 power 3. So 2 power 1 is 1, 2, 4, 8. 8 plus 4, 12. 12 plus 2, 14. 14 plus 1, 15. So this is the result, 15. And then we are having now cap exclusive R, right? So A exclusive R B. A exclusive R B is here. Exclusive R is here. If you are having that alternate input, right? So 0 or 1, we are getting 1. Then 1 or 0, we are getting now 1. If 0, 0, we are getting 0. 1, 1, we are getting 0. This is the exclusive R. So the symbol is cap symbol. So that one is here 0 or 1, 1. Then 0 or 1, 1. 0 or 1, 1. 0 or 1, 1. So we are getting now that the exclusive OR operations result is 15. And then we'll go for that not tilt operator, right? So tilt operator is here inverting. So inverting here. So that number is here. A is 10. Now we are doing the inversion. So we are getting now that one as this is, we are having now the getting now. So this is, you consider now, you take this number. We are inverting. So 1, 0, 1, 0, 1, right? So that is here we are having 2's complement 0, 1, 0, 1. Then we are getting now that one as 1, 0, 1, 0. Then we are adding 1, 1, 0, 1, 1. So that is 11. In the binary value 11, right? So that is 8, then 2, 1. 8 plus 2, 2 plus 1, 11. So that is 2's complement of that 11 is here. Then we are getting now minus 11. So this value is minus 11. So that first bit is sign bit. Sign bit, the sign is negative, and the remaining is 2's complement. So the 2's complement of that number is this one. So we are having that number and inverting that value and add 1. You are getting now that 11. The 11 is here. So that is, we are getting now the result is minus 11. So that one is here. Tilt operator is here. We are having now doing the negate. So that is called negate that number. And then we are having shifting one bit, right? So shifting one bit is here A, shift to one bit is here 20. So that is 10, 10 is a 10. Then we are shifting one bit. So 10100. So that is here. This is weight 1. This is 4. This is 2. This is 4. This is 8. This is 16. So 16 plus 4, 20. So 20 we are getting now. So shift to one bit. 1010. This is value for 10. So that is here 8 and 2. 10, right? Now we are shifting that one bit. So we are getting now 1, 0, 1, 0, then 0. So this is actually we are having 20. How it is 20? This is weightage for 16. This is weightage for 4. 16 plus 4. We are getting now that one as 20. And then we are having shift right. So this is 1010. We are shifting now. Then we are getting now 101. So that is 5. We are getting now the result is 5. 101 is 4 and 1. So 4 plus 1, 5. So 5 is the weightage. We are getting now that value. And then we'll go for assignment, right? So that is here C equal to C equal plus B. C equal to C plus B. So C is 10. and B is 5. We are getting now the result is 15. This one, right? C minus 5. So we are getting now 10 minus 5. So here C minus equal to B. C minus equal to B is 50. B equal to 10, right? C is 10 and B is 5. So that is not 5, like, right? So that is here. B is 5. So 10 minus 5, the result is 5, not 10. Result is 5, right? 10 minus 5, the result is 5. Then here 10 into 5, 10 into 5, 50. And then we are having 10 divided by 10 divided by 5, p equal to 2. P equal to 5, right? So p equal to 5. So 10 divided by 5. So the result is 2. Then here a 10 modulus 5. So 10 modulus equal to 5. So 10 equal 10 modulus 5. Right? So that is we are getting now that one as 0. C equal to 0. So we are getting now the corresponding result. Right? Then we are having that increment operator, right? So A plus plus. So we are getting now A plus plus. So that is here. This is a postfix. First it will assign that value, after that increment. So A plus plus, after that we are having 11. So here it will print 10. Then next time if you are printing, it will give 11. So that is postfix is if you are having x equal to A plus plus. So if you are having A equal to 10, then the 10 is only assigned now. X equal to 10, and then A is converted into increment as 11. So here we are having now this A is 10. Here it will print 10. Afterwards we are incrementing. Now the A is going to become 11. So we are getting now A is 11. And here we are having plus plus A. So this is prefix. So it will increment and write. So that one is we are getting now 12. Increment, right? So prefixes we are having increment and then assign, right? So that is here. If you are having that A equal to plus plus A, then it will give now increment and assign. Here this is assign and then increment. So this is postfix. This is prefix. Plus plus. Okay. Then here we are having minus minus p minus minus. So p is already 5. Then we are having this is 5. Afterwards, then it will decrement. So next time it will give now 4. And then we are having once again, then the prefix b, we are getting now minus b. Right, the exclaim here this is a question mark, right? See a less a greater than b, the condition is true, so it will assign that a value is 5, b value is 10. So we are getting now that 10 is result, right? So here already we are having a is 12, so that one is here we are getting now a already we are having now the 12 value. So 12 is here, a is already 12, so the 12 is will print now here. True condition A is told, right? Then we are having next one is the size of operator. The last operator is size of operator, right? Size of that integer. So it is 4 byte. Size of float, it is 4 byte. Then size of character is 1 byte. We are having now the corresponding operator. So size of also operator. That's all the operator in C language. So if whatever that expression if you are writing, then you have to write. Suppose we are having that minus p plus or minus root of p square minus 4ac, right? So this is our traditional mathematics. Now if you are writing that expression here, x equal to minus p, then we are having plus x1 equal to, right? X1 equal to plus, and then we are having sqrt is a function, square root of that function p star b, and then minus 4 into a into c. So this is the expression. X1 and x2 is minus p minus sqrt, and then we are having p star b and minus 4 into a into c. This is the expression you are writing now. So that one is here. You see that one, highest priority open bracket close bracket. So first you evaluate that one. Within that one we are having multiplication. So you do that one. So left to right. So you are evaluating and you are evaluating, and then you subtract. Next you have to find out a square root. We are getting now the result. Right? So add, then we are getting now the result, and you will get now the corresponding result now. So the type of operators are arithmetic operator, relational operator, logical operator, bitwise operator, assignment operator, increment decrement operator, conditional operator, and size of operator. So these 8 type of operators are there, right? So the type of operator and give simple example, then this is a program. You write it. Okay, we can stop here. We will continue by next coming lecture.